So if you're trying to calculate how much product could be produced in a limiting reactant reaction, so let's suppose you've got two substances. Let's say you've got potassium hydroxide reacting with, let's say, sodium carbonate. Okay, it's a double displacement reaction. So we're going to switch the two cations, which will be the two metals. So you'll end up with potassium reacting with the carbonate. Now crisscross to balance, and the sodium is going to pair with the hydroxide. The potassium carbonate is a solid, so it will precipitate. Okay? So suppose we've got 25 milliliters of this, and it's a 0.50 molar solution. And suppose we've got 25 milliliters of this, and it's a 0.25 molar solution. And we're trying to figure out how many grams of that is produced. Well, a limiting reactant problem is trying to figure out which one of these are we going to run out of first. Okay? It's just like baking. If you've got a recipe, you're trying to figure out, am I going to run out of eggs, butter, flour, or sugar first? So you have to work out two problems, one for each of them, and figure out which one we're going to run out of first. So 25 mils, convert it to liters, and then I use my molarity to convert to moles. Now, that's moles of potassium hydroxide. The next step is to use the mole ratio. The mole ratio is the ratio of the reactants to the products. So for every two of these, I'm going to produce one of those. Okay? So for every 2 moles of potassium hydroxide, I will produce 1 mole of potassium carbonate. And the last step is to convert back to grams. Kind of running out of space here, but this is grams of potassium carbonate. So I have to add up the weight of this potassium carbonate. Okay? So potassium weighs 39. There's 2 of them. Carbon weighs 12. There's 1 of them. Oxygen weighs 16. There's 3 of them. So when I add up that weight, at 138 grams. That goes up there. So, like I said, first step is to get it to moles, then you use the mole ratio, and then at last you convert back to grams of what you're trying to find. Okay? So when we do that, and I calculate that out, I get 0.863 grams of potassium carbonate. So based on the potassium hydroxide, I will produce 0.863 grams. Okay? So now we have to redo the entire calculation, but using the sodium carbonate, and see which one will give you the smaller number. Whichever one is the smaller number is the one you are going to run out of first. Okay? So I have 25 mils. Convert my milliliters to liters, and my concentration is 0.25 molar. So for every 1 liter, I'll get 0.250 moles of my sodium carbonate. Then I use the mole ratio. What is the mole ratio for this one? 1 to 1. So for every 1 mole of sodium carbonate, I'll get 1 mole of potassium carbonate. And then the last step is again to convert back to grams. So 1 mole of potassium carbonate is 138 grams. And I get, oh, interestingly enough, I get the same number. If this number, you have to compare the two numbers. Whatever number is smaller, that's the limiting reactant, okay? So suppose instead of 25 milliliters, let's just change this and say it was 15 milliliters. So if we pretend that, for argument's sake, that this is 15 milliliters, then instead of this number, I would get 0.518 grams. So, like I said, let's just pretend instead of 25 milliliters, we had 15 milliliters. And so if I had 15 mils, then this calculation turns out to be 0.518 grams. So whichever number is smaller, this one or this one, that is going to be our limiting reactant. So this number is smaller, so this means that the sodium carbonate will be our limiting reactant. So that means we are going to run out of this one first. Okay? So that means the maximum we can produce is 0.518 grams. Okay? That's the maximum we can produce. That is our theoretical max. Now when you do the lab, you're never going to get the maximum amount. The example I always used in class was, if the recipe says you're going to make 24 cookies, you're never able to actually make 24 cookies because there's always some batter left in the bowl, or your children eat some of the cookie dough, so you end up with less than what the recipe says. So when you actually do the lab, you end up with 0.312 grams of the potassium carbonate. Well, the theoretical maximum is 0.518, and the actual is this. So then the percent yield is what you actually got over the theoretical times 100%. So the percent yield would be 0.518, sorry, other way around, 0.312 divided over 0.518 times 100%.
Oh, did you hit a button? I'm coming.
So the percent yield would be 60.2%.